The question says that a man of mass 70 kg stands on weighing scale in a lift which is moving upward with a uniform speed of 10 meter per second, downward with a uniform acceleration of 5 meter per second square, upward with uniform acceleration of 5 meter per second square. We have to find out the reading on the scale in each case, and also what would be the reading if the lift mechanism failed and it hurtled down freely under gravity. So basically the reading on weighing scale is nothing but the force applied by the man on the ground or on the weighing scale. So let us proceed with the free body diagram in all the cases. So in first case, since the body is traveling with uniform speed, so the net force on the body must be 0. Now the forces that is acting on the body are, first is acceleration due to gravity, the force due to gravity, that is mg, and the counter force or the reaction force is equivalent to mg, that is applied by the weighing scale. So the force that is acting downward is mg, or that is equal to the weight or mass times gravity, 70 kg multiplied by 10 meter per second square, or 700 Newton. In the second case, we have the lift is moving downward with a uniform acceleration of 5 meter per second square. So the body is moving downward with a net acceleration of 5 meter per second square. Now we know that when a body is under acceleration, so inertia force acts in the opposite direction with the magnitude of mass times the net acceleration of the body. So the lift is moving down, so inertia force would be acting upward. Let us denote it by Fi, force of inertia. Weight is acting downward, that is mg. So let the reaction force that is applied by the weighing scale on the man be R. Now balancing, we have Fi plus R equals mg. Here Fi would be equal to mass times acceleration, that is 70 multiplied by 5 meter per second square, that is 350 Newton. So R would be 700 Newton minus 350 Newton, or it is 350 Newton. So the reaction force that is applied by the weighing scale on the in the upward direction would be 350 Newton, or the reading would be equal to 35 kg. Now in third case, we have lift is moving upward with a uniform acceleration of 5 meter per second square. So in this case, free body diagram would be something like this. In the downward direction, it is mg force. In the upward direction, since the lift is moving upward, so in this case the inertia force would be acting in the downward direction. So let us represent it by Fi, force of inertia, and the reaction force, that is the measurement. So in this case, R would be equal to mg is 700 Newton, we have discussed it earlier, plus Fi. Here Fi is equals to mass times net acceleration. Mass is 70 multiplied by 5 meter per second square, so it would be 1050 Newton, or it would be 105 kg on the weighing scale. Now in fourth case, where what would be the reading on the lift if its mechanism fails. So if its mechanism fail, then the reading would just be 0, because it would be under free fall, and both the object would be falling freely. Let us understand it by mathematically. So let us assume that this is the body, and since it is acted on by the acceleration due to gravity, so its force on the downward direction would be mg. Now the weighing scale reading depends upon the reaction that it would be giving in the upward direction. So in this case, since there is no reaction because both the body is falling freely under gravity, so it won't be able to give any reaction force. That's why the net force would be mg on body, on the man, and also on the lift. That is why the reaction force would be 0. So it would be accelerating independently in the downward direction. Thank you.